Hi, in this video, I'm going to show you a solve problem, and this is on finding an equation and the roots of a quadratic equation given the sum and product of the roots. Now, although we know that the sum and the product formulas for the quadratic equations is given by the sum is equal to negative b over a and the product to be equal to c over a, we will be taking a different approach. Okay, so we will not see these formulas in solving this particular problem. But what we are going to do is to apply the idea given the following information. And that is when it says the sum is 10 over 3, that means if we add the roots, then that means, or that is equal to 10 over 3. The product is when we multiply the roots, then the value is 25 over 9. Now to proceed, what we first need to set is, let's name the roots as R1 and R2. So let R1, R2 be the roots of the quadratic equation. Now once we have set the roots of the quadratic equation, we will be following the given information. The sum means if we add R1 and R2, this is equal to 10 over 3. If we multiply, that means for the product, the R1 times R2 is equal to 25 over 9. And this becomes a problem of systems of equations in two unknowns. So if you are familiar with the solving of systems of equations in two unknowns, so this is just an application of that. Okay, so basically what we're looking for are R1 and R2, but I will show you in this video that we don't even have to go directly in looking for the roots before we can find the equation. And what do I mean by that? So let me show you. R1 plus R2 is 10 over 3. R1 times R2 is 25 over 9. Now let's work on the first equation and isolate one of the roots. Let's say I select R1. R1 is 10 over 3 minus R2. Now this means in the second equation, the R1 that we can see here can be replaced by 10 over 3 minus R sub 2. So we have 10 over 3 minus R2, that's our new R1, replacing this, and then times R2 is equal to 25 over 9. And then after that, so simplify this equation, you have to distribute R2 to 10 over 3 and to R2. So this makes the equation now 10 over 3 times R2, and then R2 squared, because R2 times R2 is R2 squared, equals 25 over 9. Now let us fix the fractions. We can eliminate the fraction by multiplying both sides by the LCD. And the LCD is equal to 9. So multiply the left side by 9 and the right side by 9. 9 times 10 over 3 are 2, so that cancels 3. So that's, or basically 9 times 10 over 3 is 90 over 3. That's 30 R2. And then we have 9 times R2 squared. Let's just write that without the parenthesis. Is equal to 25 over 9 times 9. That's 9 and 9 will be cancelled. And this is equal to 25. Now let's move some expressions and let's make the R2 squared a positive 1. So the left side becomes 0 when we transpose 9R2 squared on the other side, and 30R2, so that's minus, so from positive it becomes negative R2, 25 was originally on the right side, so it will not change the sign. And then just make it appear in such a way that the 0 is on the other side. That's basically writing this first and then equal to 0. Now, if we are just looking for an equation, by the way, there are many possible equations that we can find, but to give you one, so finding an equation, so an example of the equation for this is 9x squared minus 30x plus 25 equal to 0. So how did it change from R2, so that's R sub 2 squared, minus 30 R2, or 9R sub 2 squared minus 30 R2, or sub 2 plus 25 equal to 0, how come I can now immediately say that the equation is 9x squared minus 30x plus 25 equal to 0? And with that, we are done looking for an example of the equation. The reason behind is that remember that the roots are the values that makes the equation true when we place them on the x. So it's like we're reversing the idea. Before, we place the root on the x, but since we're looking for the equation, we are reversing that process. So from the roots being placed on the x, we return to the general equation, and that is the equation that we're looking for. So the r becomes the x. So that's why our equation is 9x squared minus 30x plus 25 is equal to 0. Now, will this be true if we have used R1? Actually, even if you do the same steps using the R1 instead of R2, you will end up with this equation, 9x squared minus 30x plus 25 equal to 0. And that's just one of the many um, possible equations. Why do why do I say just one of the many possible equations? Because even the equation, when you multiply all the terms with 2, like 18x squared, 60x plus 50, when you solve for the roots of this equation, it will be the same with the roots of the first. And same if we have the multiples of these numbers, or I mean, if you multiply the coefficient by 3, like 27x squared, 90x plus 75, it will still result in the same roots. So that is why this is just one of the many possible equation. But since the problem is looking for an equation means just an example of an equation that will make, or that is based on the sum equals 10 over 3 and the product, which is 25 over 9, then that's why this is an example of that, okay, coming from that condition. Okay, now, so what if, so we are done with looking for the equation. What if we're looking for the roots? Now it will be easy now because you have the equation already set up. So to find the roots, all you have to do is to find the roots of this equation, and that is basically by factoring this. You have 3x and a 3x, that's for the 9x squared. For 25, you have 5 and 5, negative and negative. So 3x minus 5 times 3x minus 5 is equal to 9x squared minus 30x plus 25. So they're the same, so that means our factoring is correct. Now solving the x from these two factors, which are just the same, so we just have to work on one of them. So 3x is equal to 5, and that means x is equal to 5 over 3. Okay, so this is one of the roots. Okay, but since it's the other root is based on this factor, which is just the same, so that means r1 is 5 over 3 and r2 is also 5 over 3. And even if you check, are these the real roots that satisfies the sum in the given information? At the start of the problem, it says 10 over 3, and the product, which is 25 over 9. If we check the sum, 5 over 3 plus 5 over 3 is indeed 10 over 3. 5 over 3 times 5 over 3 is equal to 25 over 9. So our equation and the roots are correct. Okay, so let me just summarize what I have discussed in this video. There are two there were two objectives. First, to find the equation, an equation rather, because there are many possible equations, and find the roots. Now for the roots, definitely it is just 5 over 3 and 5 over 3. They're two but equal roots. Okay, so in finding the equation, what we set up is we started with considering the information that we have. R1 plus R2 is 10 over 3. The sum is 10 over 3. R1 times R2, the product is equal to 25 over 9. And we treated these two new equations as system of equations in two unknowns. So we just basically solve the system, and then as we were solving the system of equation, we were able to form the equation 9r squared minus 30r, uh, 9r sub 2 squared minus 30 sub 2 plus 25 equal to 0. And we did not even have to solve for the R2 because we're initially looking for the equation. And once we have reached this, what we did was we just replaced the R2 by X, putting it into its general form, because R2 is a root, it's a number that is being substituted to the X. It's the reverse of finding the roots. Okay, so from the roots we went back to the equation. Okay, now even if you continue solving for this, if you will factor this, it will actually give you the R2, which is equal to 5 over 3. Okay, so from here there are many different steps that you can take already. Okay, but again, going back to the objective, the first objective was to find the equation. So from 9r sub 2 squared minus 30 r sub 2 plus 25, just replace the r2 by x and you will get the equation. And then from here, if you want to find the roots, you can use either the equation in R2 or the equation in X. And they will give you the same numbers. R2 being 5 over 3 or X being 5 over 3, but X is basically the root. So 5 over 3, and then the other R1, okay, because R2 plus R1 is 10 over 3, all you have to do is to solve for the R1. So R1 plus R2 is equal to 10 over 3. And if you know that this is 5 over 3, then that means R1 is 10 over 3 minus 5 over 3, which is also 5 over 3. That's how we got the R1. Okay? And 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 we even look for that in a different way, 3x minus 5 and 3x minus 5, the same factors. So we ended up with the same roots, which are 5 over 3 and 5 over 3. Okay, so I hope uh, this video was able to help you solve problems similar to this one when the goal is finding an equation, or if there's an additional task, find the roots, then you can use this approach. Okay, so that's all for this video. Thank you for watching.